An inductor is a device that stores electrical energy in the form of a magnetic field. And as a consequence, the voltage across an inductor will lead the current by 90 degrees. This is in contrast to the capacitor, where you remember that the voltage lags by 90 degrees in a capacitor. Okay, so the phasor diagram for an inductor looks like this. Again, we have the reference waveform, the current, along the x-axis, and the voltage across the resistor is always in phase with the current, so that will also lie on the x-axis. And then the voltage across the inductor will lead by 90 degrees, so it's drawn on the positive y-axis. And then again, resulting from Kirchhoff's law, the source voltage is the phasor sum of the two component voltages. Okay, so here's a typical diagram for an RL circuit. And analysis of an RL circuit, very similar to what we've already done with an RC circuit. The only difference is that the phase angle is going to be positive instead of negative. Okay, so for example, we have voltage across the inductor, VL is 8.1 volts, and the voltage across the resistor, VR, 5.7 volts. And we need to find the magnitude of the source voltage and the phase angle. So source voltage, square root sum of the squares. Okay, we get 9.9 volts. Phase angle, do the inverse tangent, we get 54.9 degrees approximately. Okay, let's do one more example. Now we have the source voltage given as 12 volts and the voltage across the resistor 8.9 volts. And we need to find voltage across the inductor, VL, and the phase angle. Okay, this time we're going to need to do square root of the difference of the squares because we're given the source voltage. So we have 12 squared minus 8.9 squared. The answer is 8.1 volts. And then once we have VL, it's easy to compute the phase angle.